All right, they don't give me too much time, so I'm going to get started here. So, welcome to this session on building the perfect SharePoint 2010 farm. You'll note, of course, I have the word perfect in quotes here. There really is no such thing as a perfect farm, but what this session is about, best practices that have been learned over the past years in terms of SharePoint infrastructure and what works in terms of how you would build a SharePoint environment. So my name is Michael Noel, and I work for a company based out of San Francisco in the States. It's called Convergent Computing. We're a relatively small consultancy, and we deal with infrastructure, Microsoft-related infrastructure. So we take the particular business needs of our clients, and we address them with technology solutions. Among them include SharePoint. We've been working with SharePoint since the original release. In addition to the work that I do there, I'm also the author of several books from Sam's Publishing. The one that's the most germane to this conversation is SharePoint 2010 Unleashed, which came out a few months after the product did. That's about a 1,000-page book on SharePoint administration and infrastructure. So it is not a dev book. We don't really cover dev topics so much. We briefly do, but it is it's essentially a comprehensive guide to how you would architect and design a SharePoint environment. So this particular session, this is, I used to do a similar session back in the SharePoint 2007 days, once we had best practices around that. But once the product 2010 was released, of course, you haven't really worked your way into the best practices at that point yet. So I put this essentially session on hold for about a year until we were able to really spend a year with our clients, go through hundreds of farm implementations, and then talk with peers in the industry to see, okay, what are the best practices around deployment of SharePoint? What works? What doesn't work? What do you need to spend time with? How would you set things up? What are the best ways of setting things up? So really, this session is a lot of information all at once. I like to think of it as drinking through a fire hose. So you're not going to be able to get all of the information, but hopefully you'll be able to take 2 or 3 key pieces of information and use that for your environment. There are certain mistakes that people will often make when they're constructing SharePoint, and I'll try to address those and show you different ways that we've found around those particular caveats in SharePoint. So we'll be talking about a lot of different conversations, all infrastructure related. We'll talk about SharePoint virtualization briefly. We'll talk about enabling Kerberos within the farm. We'll talk about things like network load balancing, SSL. We'll talk briefly about some of the search infrastructure and how you'd set that up, and then the various tiers within SharePoint and how you'd architect those various tiers as well. So in terms of farm architecture, there's various ways of architecting SharePoint. Starting from the smallest environments, these are what our clients used to do, especially back in the SharePoint 2007 days. A lot of them would just essentially throw everything all in a single box and call that their SharePoint server. Now, there's a lot of reasons why you don't want to do that. It has a lot to do with the fact that a SQL server itself and a SharePoint server work in very different ways. They use their memory and their processor in very different ways, and they use their disk in very different ways. So when you share the same operating system space, you get a lot of contention between those roles from the disk perspective, from the OS perspective, from the memory paging perspective. So you really want to avoid that in most circumstances. So at a minimum, our clients generally will break off the database role from the rest of the SharePoint role. And that's the way it's worked over the years. Even with 2007, most environments would at least, at a minimum, break off the database role from the other SharePoint roles. But that doesn't give you any type of high availability. You would need to essentially move up in scale if you want to start getting a fully highly available SharePoint environment. SharePoint 2007, the smallest highly available farm was a 5-server farm. SharePoint 2010 allows you to have the same ability to fail over everything, including the index, by implementing a 4-server farm. So the infrastructure side of things is better in that you now have the capability to create redundant indexers within your SharePoint farm. So you actually can create multiple index partitions and then have those index partitions spread across different SharePoint search servers. So in this particular model, this is a 4-server farm. If any one of those servers were to go down, you would have full high availability within your environment. At the data tier here, this may be a cluster or this may be a high availability mirror. And I'll talk briefly, I've got a section where we talk about mirroring and why you might choose that as an option. At the SharePoint tier, we've got the two additional tiers of SharePoint. There's the data tier that I talked about, but then there's also the web tier, and then there's a new tier which is called the service application tier. So within those 3 tiers, you essentially architect your environment around that. And in this particular case, the service application tier and the web tier are together on the same box, which really leads to essentially a model that we like to deploy at our clients at a minimum, which is essentially, for lack of a better term, the 6-server farm. The reason why there's 6 servers is that you're separating off the tiers onto their own dedicated machines, and you're creating multiple machines for high availability. So we have two servers at the data tier, 2 servers at the web tier, and then 2 servers at the middle service application tier itself. So service applications, those include things such as search, but they also include managed metadata store, they include Excel services. There's a very large list of service applications that are natively built into SharePoint 2010. Basically, they're operating and performing tasks which are shared by multiple machines within the same farm, and also outside of the farm as well. So you can actually set up dedicated farms, for example, to run the search service application, and then have multiple farms within an organization use that or consume that search service application, which actually is some of our larger clients will do that, especially nowadays when you have one branch of the organization that created their own SharePoint farm and another branch that created another SharePoint farm, and they create a centralized, let's say, search service application farm that also runs things such as the user profile sync service, and then have those multiple farms within the organization use that particular farm. But in terms of architecting the farm itself, just from a performance perspective, from a scalability perspective, and then from a high availability perspective, we generally try to start them with 6 servers. That doesn't necessarily mean 6 physical servers. These could be potentially virtualized, and I'll talk about some of the best practices around that as well. In terms of scalability, the big thing about SharePoint 2010 is that it is now much more scalable than SharePoint 2007 was. SharePoint 2007, you were limited by things such as having a single server or single index per shared services provider. 2010 doesn't have that limitation. 2010 also built that service application tier to be highly scalable. So you can essentially start to add more machines in and give them specific service application roles to spread the load out between different servers. At the web tier, you can start to add more web servers in as well, and then configure them to be part of a network load balanced pool. So you can start to get into these really large farms that have multiple web servers, multiple servers running query, different servers dedicated to crawl, other servers that are dedicated to service application roles. It'll all depend on what you're going to use your SharePoint environment for. In the past, your database server was always the one that was the most data intensive. We actually have some farms that have certain service application servers which are the ones that use the most memory and processor because of what specifically that client is doing and how they're using service applications. So every farm configuration will vary in how it's actually implemented. In terms of virtualization, last year one of my most popular sessions, and the one that I did the most around the globe, was a session on SharePoint 2010 virtualization. So I'm going to try to condense that hour and 15-minute session down to about, real quickly, 10 minutes here. But the long and short of it is that it is possible, and you are capable of actually entirely virtualizing your SharePoint environment. We have clients that do that. They have specific reasons why they go ahead and do that, and not every organization is going to virtualize all of their components. For example, many of them may decide to keep physical SQL database servers, but may virtualize their web tier and their service application tier. Or other ones may just virtualize their web tier itself. At a minimum, generally, our clients are virtualizing their dev environments and their test environments, but we have a lot of organizations nowadays that virtualize a lot of their production infrastructure. So again, it really depends on what you want to do. Virtualization, just for the sake of virtualization, doesn't make a lot of sense. But if virtualization is part of your disaster recovery strategy, then, for example, if you're using something like Site Recovery Manager with VMware, then it makes a lot of sense to virtualize everything, all the components, because you can actually snapshot your entire farm from one data center to a different one in a different location. So different virtualization infrastructure that we've seen, starting from the smallest. This is essentially a model that in the past would have had everything installed on that one server. These are the clients that only have a single server that's dedicated to SharePoint. They would have just put the SQL Server role and all the SharePoint roles on the same machine. Well, as I mentioned, because of the way that the OS has used their memory and the way that they use paging and those types of things, you generally want to avoid that kind of scenario. So what we've recommended with those smaller clients is that they actually deploy that one machine as a virtual host and then actually deploy different virtual guests running underneath that machine. One that's dedicated to the database role, another one that's dedicated to be the production farm server, and then maybe even another one that's a test farm server that's part of the same environment. So it allows you to have dedicated machines for each individual farm, all running within the resources of that host. Now granted, there is some overhead to virtualization. You're going to lose maybe between the realm of 3% and 5% of the available capacity of the host itself by virtualizing, just because it has to do that virtualization work. But what you gain is the fact that it will actually allocate a specific set of the memory on that host for the one OS of the SQL Server, and then another subset of the memory for the OS of the SharePoint server. And what that does is it allows it to be segregated into its own piece. And we've actually found, doing some different performance tests, you can actually get better performance out of an environment that's virtualized like this than you would if you just threw everything on the exact same host itself. So at a minimum, we have clients that look at this particular model. Other clients may just have 2 servers, and they may want to deploy a fully virtualized environment across those 2 servers that's also highly available at the same time. Well, I mentioned, of course, previously you'd want to go with either the 4-server farm or the 6-server farm as part of that. Virtualization allows you to have the flexibility to actually expand the environment out. So you can do things that you wouldn't be able to do if you just had physical machines. So if you can only provision 2 actual physical servers, turn those 2 into hosts, and at that point you have the flexibility to virtualize your SQL tier. You can virtualize your production farm. You can throw a test farm into that environment. You can throw a dev farm. You can have a SQL witness server that will automatically fail over the databases from the principal server over to the mirror server in the event of an outage of this primary server right here. So it gives you design flexibility that you wouldn't normally have if you didn't use virtualization. And honestly, our clients are generally deploying virtualization because they want to do the cost savings and they want to consolidate and they want to have smaller space for their environment. And those are all laudable goals. But, as an architect itself, my main reason that I prefer virtualization is that I have the flexibility to go and deploy SharePoint any way I want, and also to deploy SharePoint any way I want as quickly as I want. One of the things that we do with our clients, for example, when they use virtualized environments, is we use tools like Microsoft's System Center Virtual Machine Manager, which allows you to actually to create a template server that's a SharePoint machine that can be quickly brought into a farm. So you can actually get it down to a process, and one of the things I would demo during that virtualization session I did last year is a process where you actually go through and create a brand new SharePoint server and add it into a farm or create your own farm from scratch. And we've got it down through PowerShell and through using virtual templates to having a farm that's brought up in less than 15 minutes. So you actually have that kind of flexibility. You'd never have that kind of flexibility in a physical environment. It just takes too long to go through and provision the servers. So there's some big advantages to using virtualization from that perspective. This particular model here actually doesn't even rely on shared storage. In this particular model, what's happening is that all the SQL databases from this server are being replicated over to the mirrored server here. They have their own separate sets of storage. So it's actually relatively low cost from the perspective that it's not even using SAN, but it's using technologies that are out of the box from Microsoft, which include SQL database mirroring, included in the standard edition of SQL Server, as well as just taking advantage of virtualization to spread them out between the 2 machines. So this is, again, just one option, but we're seeing a lot of clients, particularly the ones that may be more resource constrained and only have so much equipment, deploy something like this. Other models generally are going to have a mix between what's physical and what's virtual. And a lot of that has to do with the fact that, well, your SQL data tier is highly data intensive. It requires a lot of processor, it requires a lot of memory. So you end up allocating a lot of resources to the individual virtual guest. And combined with the fact that on a SharePoint server itself, there's a limit on a virtualized guest to how much memory you can allocate that it will actually be able to use appropriately. And that has to do a lot with the way that the virtual host is allocating the memory between the different cores that are there. Without getting into too much specifics, the long and short of it is that you can't just add more RAM to a virtual guest session and expect it to get better performance. There is a sweet spot that you'll hit, depending on the architecture of your virtual host, where you won't be able to add any more RAM. So the downside to that is that your database role that requires a lot of memory in a lot of cases may not necessarily be virtualized. And we have a lot of environments that don't virtualize it. So they may take and they'll virtualize and they'll have, the broken off, in this case you'll see the production farm with the broken off web servers, the broken off service application servers, and then they've got their data tier down here, which may consist of a cluster that's sent over to another database server that's used as a mirror, or it may actually have your SharePoint databases broken off by a SQL server. Well, I talked about scalability earlier. It's not just scalability at the SharePoint layer, it's scalability at the SQL layer. What many of our clients do, actually from the beginning, even when they're doing an installation, is they'll create 3 different aliases for their SharePoint environment, and they'll point them all to the same SQL server initially, but then later on they split out their databases and they move databases between SQL servers, so then they just move those aliases between the different machines. So they may have, in the future, they may have all of their search databases on one SQL server or on one SQL cluster, and then their content databases on another SQL cluster, and then there are other types of databases on a third one. SQL optimization is a huge area, and we'll briefly touch on it here, but there's a lot of things you can do in terms of optimizing which type of database is on which type of server. A content database is primarily used for reads and then a few writes every once in a while, whereas other databases are actually constant writes that are being made to those databases. So depending on your types of databases, you can optimize them by either moving them between servers or at a minimum moving them between disk spindles on individual machines themselves. From a scalability perspective, from virtualization, you'll also see a lot of scenarios where there are very large environments that can be scaled out quite easily using server virtualization. I think I saw a tweet from the other room. I didn't catch the keynote because I was setting up here, but Microsoft mentioned that Office 365 is running completely virtualized. So I mean, we've actually gone through and we've had clients that have large, multi-terabytes, tens of thousands of users that are entirely virtualized. So it is possible to do it. You just have to architect your host and your guest infrastructure properly. If you're really interested in the specifics, the details, you can download my slide deck from slideshare.net. I actually have my virtualization slide decks, a couple different versions that I've done throughout the last year. So that goes into a little bit more specifics, and it has some examples in there. But long story short is that it is possible to fully virtualize an environment if that's what your goal is to do. But that said, remember, there are caveats associated with it. If you don't architect it properly, that will be your Achilles heel. You'll have the performance issues that are associated with the improper architecture. So I've seen that many times. It can be done, but it has to be done the right way. A couple other best practices around content database and site admin architecture. Few things that I've seen get our clients or where they get themselves into trouble from the beginning is the scenario where somebody set up SharePoint and became very popular, but from the beginning it was always set up with a single site collection in a single content database. Well, as you may or may not know, a site collection itself can only live within one content database. And that content database can grow very large very quickly because SharePoint natively stores all the documents, which it refers to as blobs. It stores them within that SQL content database natively. Now, we'll talk about RBS in a second here, but in any case, every version of that document is also stored as a blob. So a 5 megabyte document with 5 versions is 25 megs. The size balloons very quickly. So if you're a SharePoint admin, you'll know you start to get hundreds of gigabytes in a single database. So what a lot of our clients, what we try to encourage them to do when they're designing definitely at least a document management environment for SharePoint is to start from the beginning by distributing your environment as much as possible. Even using technologies like RBS, again I'll talk about that in a second, which allows you to take the blobs out of the database, doesn't necessarily remove you from having or wanting to go through a concept of actually distributing out those content databases right from the beginning. So one common way of distributing them, and that kind of graphically illustrate here, let's say you have a document management environment, home.companyabc.com. There's a managed path for different departments within the organization, and each department has their own site collection. Each site collection is part of its own content database. You don't want to go crazy and have too many content databases, but you can have a fairly large number of content databases running on a box. So by doing it this way, you actually spread across your data. So rather than having everybody in one big site collection, which becomes extremely difficult if you need to extract out data later on, it's not so easy to just chop up that site collection and move content, at least not with what's called a full fidelity move. So if you need to move things with full fidelity, you end up using third-party products in most cases. So if you can, from the beginning, start from a distributed site collection infrastructure that allows you to spread out your content. Now, if you do have really, really large content databases, which, well, what does that mean? Microsoft today says you don't want to get bigger than 200 gigabytes. It doesn't mean your environment's going to shut down when you hit 200 gigabytes. Truth be told, I have clients that have content databases that are over 1 terabyte in size. Now, imagine trying to spool that off of tape and doing a restore. Not a pretty picture. So you want to avoid that kind of scenario. For those clients, we are looking at a data management perspective of them using things like remote blob storage. I mentioned the documents themselves are stored as blobs. That stands for binary large object. There's a concept within SharePoint 2010 called RBS, which usually stands for Royal Bank of Scotland, but in this case it doesn't. Which, by the way, I've heard through the grapevine that they actually use RBS, which must be confusing. In any case, so RBS itself, remote blob storage, allows you to pull the blob and store it in a different location. Now, it's an API. Most of our clients actually use a third-party product, and there's a bunch of third-party vendors here. They have different RBS offerings. The SAN vendors have them. There's offerings like StoragePoint, what have you. But basically, it allows you to take that blob and store it in a separate location from your content database. Now, since approximately 90% of the space in most content databases is blobs, then you end up actually recouping approximately 80 to 90% of the space of that content database by moving the blobs out. Now, Microsoft does have an option natively within the tool called FileStream that allows you to actually pull off the blobs and store them in a different location without using third-party. But in my opinion, that's more of essentially just a reference type of a tool or demo type of a tool. It's not something that you would generally use in production, but we do have a few clients that are using it. And truth be told, if you end up with a SharePoint Foundation implementation, that's how Microsoft allows for the databases to stay relatively small, and actually they'll pull the content out via FileStream with RBS. But again, for smaller environments using something like SharePoint Foundation, rather than most of our clients that we're dealing with will go third party when they're doing RBS itself. In terms of optimization for the SQL databases, there's a couple things that you can do that are actually quite easy that don't get done a lot. The first one is to actually take your database files and break them up into multiple physical files themselves. So you take the MDFs and distribute them out into different NDF files. So it's literally taking a content database and splitting it into multiple broken pieces, one of which is on a single file, a disk, a set of a SAN volume, for example, and another piece of it that's broken off onto another SAN volume, et cetera, et cetera. How many you break it up to? There's really no perfect answer for this. You'll see some guidance on the internet that says to break it up by the number of cores you have in the machine. It's not actually the number of cores. I want to clear up a misconception here. It's actually the number of physical processors is the most ideal configuration. So if your SQL server has 4 physical sockets for processors, so let's say it's 4-way and it has 4-way quad core, so it's 16 cores, you'd actually break up your database files, ideally, into 4 pieces. Now, if you broke it into 16, it's not really going to affect things, but you don't get the better performance overall as you start to go beyond the level of the number of physical sockets you have in your machine. So general guideline, break it up. If you have just 2 physical sockets, break it into 2 pieces, and then break those 2 pieces across file volumes. So in a perfect world, this volume here is a striped disk set on a SAN. This is another striped disk set on a SAN, and they're all highly functional, and they allow for a great deal of performance. And what happens is that as people go in and start writing into those volumes, they're being written across on a set of 4 different SAN volumes at the same time. You can get blazing fast performance out of your SQL environment just by doing something as simple as this. At the same time, you do the same thing with your tempDB. TempDB, you want to do the same process. You want to break it out into multiple groups and split that across multiple machines. It's relatively straightforward to do this. It doesn't take a very complex set of processes to go through and break up these actual database files. But by doing that, you can get greater performance overall. I mentioned earlier, too, sometimes with some of our clients, we'll actually specify that this volume is more of a write volume, and then this volume is more of a read volume. And we'll put different SharePoint databases into those volumes based on the type of database that they are. And that's something you'll want to work with your SAN vendor on, because there's different types of SAN configurations that are better for writing. You can have a RAID 0+1 versus other ones where reading, put a RAID 5 in place. You can optimize and get the best value for your money and split those databases up by the types of writes that they do. Other things you want to, and just for an example here, I put an example. 100 gigabytes content database on a 4-way SQL server would be broken up into multiple actual physical files themselves. And in addition to breaking them up by file, what we generally do with our clients is we also pre-size them. If you don't pre-size, what happens is that when that database file needs to grow, it actually will put a quick temporary lock in the machine itself. And so there's a performance penalty when it has to grow that database. Every time it has to grow that database, you're running into performance issues when that actually happens. So what we generally do at the beginning of a project when we're designing SharePoint is we'll go through and pre-size each one of those content databases to be approximately as big as we think the data is going to grow within the next couple of years or so. So if we think that that individual departmental site collection within that content database, similar to the diagram we saw earlier, is going to be around 100 gigabytes in size, we'll take the physical database file itself, pre-size it as 4 pieces of 25 gigs apiece, spread it across those volumes. It's now one big contiguous space, which means that now when there's writes happening to it, it doesn't have to go and expand the volume. It doesn't have performance penalties. There's not locks and those types of things. You also avoid fragmentation issues. If you have them all running on the same volume, you can pre-size them so that they're all in their own separate pieces at the same time, rather than having the actual physical file itself fragmented across the volume. So that's a good best practice to follow, and it's an easy best practice to follow as long as you have the space. TempDB. The guidance around TempDB is to also pre-size it. Something that most people don't realize with the TempDB file, the default is 8 megs. The default will always, the TempDB recreates itself when you reboot the machine. So after you reboot a SQL server, even if your TempDB file has grown, which it will, of course, it'll reset itself down to 8 megabytes when you reboot that box, and it'll have to grow again. Every time the TempDB grows, there's also a performance penalty. So the TempDB file, which is used for every transaction that goes in and out of SharePoint, will grow and grow and grow over time as that SQL server is up. And then you'll actually slowly, once it gets big enough and it doesn't have to grow anymore, your performance will get better. And you're thinking, this is great. You reboot the machine and the performance goes back down again because it actually has to recreate that file. So what we do with our clients is we'll actually create, we'll pre-size the TempDB. You specify how big it is, break it up into multiple file groups based on the number of processors on that machine, and then you get better performance right off the bat just by doing something like that. By the way, side note, if you are using SQL transparent data encryption, which I'll talk about briefly, that actually the TempDB instance itself is encrypted. Generally in those scenarios we have 2 instances then, one for the encrypted databases and one for the regular databases. That way you don't have the performance penalty of having the TempDB encrypted. Okay. Mirroring. Again, this is like a lot of information at once, drinking through a fire hose. I apologize, but database mirroring. It is, in my opinion, it is, I don't want to say better than clustering, but if I have to choose between clustering and mirroring and I have 2 servers, I generally go the mirror route. Why? Because I can actually get a copy. It's like a constant backup of all my databases on a different machine. So SQL mirroring works by a concept where you take your databases and you mirror over all of those databases to an equivalent to another server, a principal server on the other side. The vast majority of databases in SharePoint are supported for mirroring. There's a few exceptions to that, but all the content databases are supported in synchronous mirroring scenarios. So there's 2 different types of mirroring. There's what's called synchronous mirroring and there's asynchronous mirroring. The difference between the 2 is that asynchronous mirroring is generally used in WAN, cross-WAN scenarios, and it's only available with the Enterprise Edition of SQL Server. Asynchronous mirroring has what's the safety level turned into off, is what they call it. But what it is that it doesn't wait for the data to be written into the other side before the transactions are committed. They're instantly committed on the principal server, which means you could potentially lose data if there's an outage, because it's not waiting for that data to be transmitted to the other side. But in a WAN scenario where you have a large degree of latency, or if you have lower bandwidth, in fact, it's less than a gigabit of bandwidth, anything less than that, and anything less than an average of 1 millisecond of latency, you can't use synchronous mirroring across that connection. You have to use asynchronous. So asynchronous mirroring, it's pretty much only supported to do it on the content databases and actually the secure store database. But just those two databases, it's a majority of them are the content databases are supported when you're doing asynchronous mirroring. But synchronous mirroring, the rest of the databases, except there's a couple of them. There's the user profile databases aren't supported, and there's one of the search databases. But in any case, the majority of them, in that case, then you can actually synchronously mirror over to the other server. And since SharePoint 2010 is now mirror aware, you can now fail over to that other server as well quite easily. In terms of the different options, this was the first option here. This is what's called a single site, high availability mirrored farm. Everything all within the same site. The next option here is essentially a variation of that. That's if you're one of the lucky people that has a huge amount of bandwidth between facilities. And we have some of these clients, for example, that may have a campus, or between campuses they've got a connection to a data center that's 30 miles away or what have you, or it's 100 miles away. And they have a copy of their databases on that other machine over there. And so it's the same concept. You're using synchronous mirroring since we have less than a millisecond of latency and greater than a gigabit of bandwidth. And we're allowing us to fail over to the farms, the actual SharePoint members of the same farm. So in this case, we've got multiple servers that are running the same tasks. And when the whole site goes down over here, you can fail over these servers over to these databases here. And you just have to go through and update the DNS records to point to these SharePoint servers on this side. If you're using something like an F5 load balancer or some other global load balancer, you can actually have that process itself automatically set up to fail over to the IP addresses in this location as well. So it's just really taking myside.companyabc.com and home.companyabc.com, taking those records and failing them over to this side and turning these databases on to actually allow them to be used, to continue to be used. And since it's synchronously being mirrored, all of these databases are the exact same version that they were when they failed over to the other side, which is why it's supported to do things like the config database as part of a synchronous mirroring scenario. The last scenario is the one I mentioned. This is the cross-WAN scenario. This is where you're just taking your content databases and asynchronously mirroring them over to the backup data center. Now, you do need SQL Enterprise Edition running on both the principal and the mirrored target. So in terms of licensing, now your licensing costs have gone up 5 or 6 times if you've ever priced out Enterprise Edition. But if you do have the Enterprise Edition, it opens you up to the ability to do things like asynchronous mirroring in cross-WAN scenarios. We have clients that use that as their primary data backup strategy. And what you can do in this, there's actually a couple different ways to fail over. They all involve setting up a farm in the other location, and it's a separate farm completely, because it hasn't changed the guidance around making sure that you don't have a farm that spans across slow WAN links. You generally want to have a farm within the same highly connected area. But in this case, it's a separate farm that you connect those databases up to. Now, it could be a read-only farm, so you could set up a scenario where this site is down, but it's only down for 12 or 24 hours, and you set up the SharePoint environment to be read-only for that period of time. That way, what you can do is that when this farm comes back up, when this site comes back up, you can just reestablish the mirror connection, and there's been no changes made because this is just read-only over here. You can also set this side up. You can turn it to be write. But once you turn it to be write, the only way to go back is to reverse the mirror this way, synchronize everything back up to this other side, break the connection, synchronize it back again. So it's a more complex process if you actually go through the scenario of failing over the entire farm. But let's say in scenarios where your data center is, let's say, San Francisco Bay Area, earthquake, takes it down. These are things we deal with in our data centers a lot. Same concept is you would say, okay, well, it's going to be down for a week. let's turn it on the other side and actually allow us to bring this farm online. But a couple things to note. You need to make sure that every service pack, every cumulative update is exactly the same. Every feature that you've installed, all of that has to be done to both farms. So you need a good change management process to be able to do this. Otherwise, you'll try to connect those databases up, and it'll be a different database version than what it's expecting, and it won't work, or things won't render properly because you didn't have the right features installed into that farm. So make sure you're configuring them exactly the same. In terms of hardware and software, some general guidelines around this. A few things I've seen people forget about. One, don't forget about the fact that that index server requires disk space as well. And the amount of disk space can vary depending on what you're actually crawling. We've had clients that will go and configure SharePoint because it's enterprise search to go out and crawl their 4 terabyte file server store. That's great, and it allows you to do that, and you can get the search results back and do full text search, and it's security trimmed as well. People don't realize that. The security trimming applies to file server locations, but don't forget that it has to store that full text index somewhere. Depending on how much actual text exists within those files, it'll vary. It'll actually be between 5 and 30% of the actual size of what you're crawling, depending, again, on what you're crawling. If you're crawling text files, it's going to be higher. If you're crawling images, it's going to be much lower. So make sure you're setting up enough space on the SharePoint servers for the search service application index itself. And by the way, on that note, in case you weren't already aware, SharePoint has essentially 2 search engines now in SharePoint 2010. There's the native search engine, which is essentially the newer version of the one that was included in 2007. And then there's a completely different product called Fast Search that Microsoft actually went out and acquired a company out of Oslo called Fast. And they bought that product, they integrated it into the line, and now it's a completely different search tool. So we have some clients that deploy Fast Search rather than SharePoint Native Search. And just understand that Fast Search it gives you a level of capabilities above and beyond native SharePoint 2010 search. So it's an additive thing. You don't actually lose capabilities going to Fast Search. The big thing that gets our clients to do Fast Search, incidentally, is the thumbnail preview capabilities. There's a huge list of extra features that it does, and I'm not going to go into too much detail, but the thumbnail preview thing is the one that really gets a lot of our clients interested in this. When you do a search results, you get the actual document. You can flip through the pages of the document without actually opening it up. So that's useful. A lot of people like that feature. In terms of when you're allocating the resources, it's generally considered, you go to the database server first, then the search service application, which is oftentimes the hungriest service application, and then other service application roles. But as I mentioned previously, in some cases, different clients, they'll have a service application that's used so extensively that it needs more resources than even the SQL database role itself. But the majority of service applications actually store common data at the data tier. So you'll see, of course, when you install SharePoint 2010, if you ran through the config wizard, you've got 18 databases right off the bat. Right? That's because the service applications all create their own custom databases. And by the way, on that note, going off on another tangent here, you'll note as well, if you use the config wizard, you get these big, ugly database names with GUIDs on them. Our best practice nowadays is actually to use PowerShell to configure everything. So we have a series of PowerShell scripts, and I'll give you the link to them. But they actually go through and automate the provisioning of your farm with custom database names. So what I like to do, for example, is have database names that start with the farm name. So it'll be farm name underscore config, farm name underscore content, department 1, farm name underscore services application 2, that kind of thing. So that way you can easily tell in your SQL Server which databases are associated with which farm, and you don't get these hyper complex GUID names in your database. Other things, in terms of the OS itself, we're starting actually to deploy new SharePoint servers running Windows Server 2008 R2 with SP1 already embedded into it. We've been doing Windows Server 2008 R2 for quite some time. I particularly like it because if you use the native 2008, you have to go through and modify the application host.config file to get Kerberos to work properly, and there's these custom things that you have to do. So preferably you're using the latest version of Windows Server, so that would be Windows Server 2008 R2 with Service Pack 1. You don't necessarily need Enterprise Edition, although it doesn't hurt to do it. But some of our clients, when they're physically buying SharePoint servers, they ask, well, what do I need, standard or enterprise? You don't really need enterprise except for if you're running the SQL role and you need to use SQL Enterprise Edition, and which needs Windows Server Enterprise Edition as well. In terms of the SQL Server, if you have a choice, preference is to use the latest version of SQL, which is SQL Server 2008 R2. It's not just a preference when it comes to Power Pivot, it's required for Power Pivot. So if you are using Power Pivot, you will need SQL Server 2008 R2 analysis services. There's also some huge improvements made to SQL Server 2008 R2 reporting services. So if you're going to use reporting services as part of SharePoint, you'll generally want to do that. From the database layer, the big advantages actually come around the mirroring space. The mirroring has been greatly improved in 2000. It was technically in 2008 itself. You could use 2005 if that's what your organization's validated, but that's, ideally you would go to the latest version. We've been using that on a lot of our bigger clients as well. In terms of the installation, best practices around this. Best practice, you've probably seen this over the years, Microsoft has been talking about this, but best practices from multiple service accounts. At a minimum, I'll tell you what you need to do at a minimum level, is make sure that the accounts that run as your application pools do not have any type of advanced rights on the individual machine itself. Especially don't make them a domain admin, because you're just asking for trouble. From putting my security hat on, if I were to attack a machine and I were able to, quote unquote, own it, I would run as the app pool identity account. I do not want that account to have any additional rights other than what it needs, which really it's just creating a service account, and then at that point you don't need to give it local admin rights or anything to that box. You just add it in as the app pool identity account, and it's an account that has the rights to run that individual app pool. Right? So at a minimum, make sure your app pool identity accounts are not the same as the rest of the accounts, and also make sure that your search service application role doesn't have isn't the same account as your default crawl account. Because that's, if you do, you actually end up seeing unpublished content come back in search results. So, and preferably, you go through Microsoft's guidance around what accounts to actually use. So here's an example using our kind of default set of accounts, what we'll go into with clients. There's a setup account, which is the only one that has the local admin rights on the SharePoint servers that's used to actually install the SharePoint bits. SQL itself has a completely different set of admin rights. The actual rights that you need on the SQL server are actually only DB creator and security admin. And that's only when you're creating databases. Otherwise, it'll have the login to be able to be a user on the databases that it creates. So once you've actually created the databases, you can actually pull those rights back. And we've had hyper secure SQL DBAs that will go in and will create our SharePoint databases, and then they'll lock us out completely. And it's technically fine as long as we have we're the user associated with those databases and we have the rights to get into the server. We don't need those rights anymore. You definitely don't need any type of local admin rights on the SQL box. That's a big no-no in terms of the configuration. You want to have a farm or multiple farm accounts that are used to log into the farm. That may be your user identity as well. It could be your admin account that you use. And then you'll want to have a separate account for search, a separate account as the content access account for the crawl account, and then user profile sync service will want to have its own separate account as well. User profile sync, I think I have a slide in this that says this later on too, but it is the most complex and headache-inducing service in SharePoint 2010. And I think Spencer later on today is doing a session just on it, which is good because I usually redirect people to his blog for setting up UPS. But long and short of it is that get some help when you're setting up UPS. We've gotten to the point where on a project, it's a line in our project plan in terms of we have to track it as a separate item and we have to assign a certain number of time that's used just to configure UPS, which is how complex that is. In this case, you'll see I have a couple different app pool identity accounts. Thing to note, every application pool that you create on your SharePoint server takes about 800 megabytes of RAM on that individual web server. So don't go crazy with your app pools. If you have 50 web applications, think about, do you really need to actually break out each web application into its own application pool? Because oftentimes you can have a single app pool that's actually shared by multiple web applications, and that would reduce the footprint on those SharePoint web servers. And I mentioned earlier the web role was the least hungry. Well, that's in normal situations where you only have a couple different web apps and a couple different application pools. In scenarios where you have really complex and multiple app pools, you've got a huge amount of resources that are being taken up on that box. In terms of flexibility during the install process, I hope you know this by now. This has been harped on over the years. Don't do standalone for any type of production environment. I don't even do this for my tests or devs or any types of environments myself. I think I did this way back in the day just to test what would happen with it and see how bad it was. Yeah, anytime you're installing the server, do a complete installation and do a server farm, not a standalone installation. That way you have full flexibility to add or remove it into any farm. You can take this server after it's been installed. Once you get up to the point where it says, would you like to run the configuration wizard after install, you can uncheck that box, sysprep that machine, and you can take it anywhere and use it as a SharePoint server. In fact, it's that concept that we use as part of that scenario where I said virtual machine manager to automatically provision new machines. You just take a machine that's already been installed with SharePoint, shut it down, sysprep it, take the SIDS off of it, and then at that point you can use that machine and add it into any farm. And that's that part of that process that I demoed in the virtual lab. Other things, just kind of a side note, if you're going through the GUI to do the installation, it helps you if you put in the index location right here at the beginning. I oftentimes, kind of our standard build is to have that on a separate volume than the OS. So we have the OS and the SharePoint binaries on one, and then we'll oftentimes have the index plus different types of logging and those types of things on a separate data partition. And when we do this from the beginning, again, we can create a template off of that. So like our virtual machine template, we'll have a C drive and a D drive that's created. The C drive has SharePoint installed. The D drive has the index server's role and the index already installed as well. The command line installation, I mentioned that we have a series of scripts. Those scripts are actually originally written for the SharePoint 2010 Unleashed book. You can download them. And the link to that is here. I've concatenated the link. This will take you to a good friend of mine's blog. His name's Tony Frankola. He's a SharePoint MVP out of Croatia. He originally collaborated with me and with another gentleman, Mohamed Amar, who's a SharePoint MVP from Jordan. And we worked together to create these original scripts for the book. So on his blog is the link to these two scripts. These are full installation scripts. What they do is they walk you through a process where it asks you questions and says, what would you like the name of the farm to be? Would you like to provision this service application? Yes, no. If you say yes, then it goes through and provisions the specific service applications. And we've got it down to as automated a process as possible to date. Now, when I say as possible, there are a few applications which don't really work too well in terms of provisioning them. At least there's some issues with provisioning them through the command line. So we haven't really gotten to the point where it's perfect yet. But as new releases come out for SharePoint 2010, within hopefully the next year or so, we'll have essentially a script that will go through and automate the creation of everything from scratch, including Performance Point, including Web Analytics, and including, of course, the notorious User Profile Sync service. That's much more complex to set up, as you'll find out if you go to Spence's session later on today. Configuring the farm. Couple brief things on this one. We're running out of time here, but when you do create it, eventually you'll want to get to the point, ideally, where you're running on a common port for SharePoint Central Admin, you're running with a common name, and you're running it with Kerberos and SSL. The perfect world, you connect to your SharePoint Central page from any web browser in your organization by going to https://spca.companyabc.com. which takes you to a load balance series of front ends which are running the SharePoint Central Admin servers, which have an SSL certificate configured on them to protect the passwords that you're entering into them, and which are set up for Kerberos for best practices around security and best practices around those types of things. So ideally you do that. From the beginning, though, when we're generally configuring it, we start with you use a port that you could remember very easily, like 2010 or 8888, and then you configure it for Kerberos at some point. Couple other things to note, SQL aliases. In SharePoint 2007, we always use SQL aliases because we needed them for mirroring. You couldn't, because SharePoint 2007 wasn't mirroring aware, you would use the SQL alias to point it from the old server over to the new server. You can still use the concept of a SQL alias. In fact, we still use them a lot because it gives us the best flexibility in terms of moving your databases from one server to the next. So I mentioned earlier the concept, you have a couple different aliases that you create, and you point those aliases to, let's say, even initially the same server, but then you split them off and you point them to different servers later on based off of where you want to move those databases or move those content databases. We've had some clients take this to the extreme where every database that they reference has a different alias, and that way they can quickly move things around. That's probably a little bit overkill because you can just change the content databases. You can detach it and attach it again. So I don't think you have to necessarily go to that extent. But at a minimum, maybe for some of the service application ones, you do want to consider something like that because it's more difficult to change their database location. Network load balancing for the front end. Best practices around that are if you have a hardware-based load balancer, use it. They're great. I love dealing with F5s and some of the Citrix NetScalers and Cisco content switches and all of that. If you have something that's in place and it's built for that and it's supported, which most of them are, use it. Just make sure that you're enabling stickiness for the sessions or session affinity. Has different ways of describing it. Basically, it's when the user starts their session, they'll continue to go through the same SharePoint front end until that session's over. That way they're not being flipped around from one server to the next for every request that they're making. The reason is SharePoint is session-based, so if you break the session, it'll actually reset their individual session, which is fine for a failover scenario. They might have a little bit of a disruption. If you lose a server, you want it to be able to fail over. But by default, when you're losing a load balancer, make sure you have it set up for session affinity rather than have it be split around from one machine to the next. If you're using software-based load balancing, which is also good, it's better than nothing, a couple things to note. If you use unicast, you have to use 2 NICs on each server. One NIC for communication between the nodes, and the other NIC that's actually the one that the end users connect to. And that's because in unicast mode, they actually share the MAC address. All of the machines share the MAC address, so they can't communicate with each other over that NIC that everybody else connects to. So if you're using unicast, bear that in mind. If you're using multicast, 2 things. One, your routers actually have to be configured properly, so make sure your network guys are aware that you're using multicast. You'll note that you may be able to ping it on the same network segment, but you get outside that network segment and suddenly you can't ping it anymore. That's usually a multicast problem on the routers. The other thing is if you're using this in a virtualized environment using VMware ESX, there's specific guidelines on how to actually configure your network properly so that the multicast works. So make sure you check out, do a web search for multicast running on VMware if you're running into issues with multicast. I've put some examples, give you an idea to illustrate kind of a standard configuration for software-based load balancing. We got 2 servers here. Let's say call them IP address 101 and 102. We have a clustered IP, a VIP for the cluster, so SPNLB that points to the actual network load balance cluster name. SharePoint Central Admin is load balanced. SharePoint SMTP for your inbound email. Don't forget to load balance that, otherwise that's not redundant. And then your different web applications that you have set up. And the reason I have a unique IP rather than using host headers is because I like to use SSL even when I'm internal on SharePoint to protect and encrypt that whole process, the entire traffic itself. And speaking of security, there's multiple types of security, multiple layers in SharePoint. Starting from your best practices around infrastructure security, which includes the service accounts that I talked about, and it also includes Kerberos, which we'll briefly mention at the end. Then there's data security itself. That's you're setting the proper ACLs and also concepts around role-based access control, only allowing, dropping somebody into a group in AD and automatically having them gain rights to everything that role entails. And then transport security, so security in transit, which includes SSL from the server to the client, or IPsec from, actually that should read from server to server, as well as inbound security from the internet, which includes things like Microsoft's Threat Management Gateway, Microsoft's Unified Access Gateway products, which allow you to do SSL VPN into your SharePoint environment. So, and there's also, by the way, a whole other category called rights management. You can use Active Directory rights management services to restrict the ability to print, to restrict the ability to cut and paste content directly out of your SharePoint content. So make sure you're addressing all the different layers depending on what your particular security needs are. The SSL certs, I briefly mentioned this, but I'll say again, highly recommended to do SSL definitely externally, but also internally as well. Sure, with modern switches, not everybody can just plug into and sniff all the packets, but your network admin can, and you don't necessarily want your network admin to be able to sniff the SharePoint packets that are being sent and to be able to look at a confidential document that's stored within SharePoint. So it's a hole unless you use SSL encryption itself. And you can offload it with the load balancers, SSL offloaders. UPS, all I'll say about UPS, if you're really interested in it, go to Spencer's session this afternoon or go to his blog, which is harbor.net. And I've got a couple more slides in here, which are just if you want to download them and go through the process. A few other best practices about enabling diagnostic logging and the usage and health data collection service. So I've got some steps in here and also in the book as well on how you'd actually go through and configure those. Few last best practices before we jump into Kerberos. If you're doing the inbound email enabled content piece of this, create a dedicated OU to create those contact objects. It's very powerful, so go through the process of that allows you to email directly into your SharePoint environment. Make sure you understand AAMs, which is a huge thing. People don't understand that a lot. That gets them into a lot of trouble. And then don't forget about things like antivirus. Microsoft has a product called Forefront Protection for SharePoint. It's actually a really good tool for antivirus. There's also third party as well. And backup. Microsoft's backup tool for SharePoint is System Center Data Protection Manager, but there's a lot of third-party backup tools that are out there as well. Okay, lastly, Kerberos. Long and short of it, Kerberos came out with Windows 2000, right? NT-LANMAN, the default, is NT-level technology. It really hasn't changed much since 1996. So you really don't want to be using NT-LANMAN. I can grab your password using NT-LANMAN, grab the hash, and decrypt it using brute force techniques fairly easily. Depending on how complex your NT-LANMAN is, the hash is, there's various levels of encryption on it. But if you're using the default, and depending on what your force mode is in Active Directory, it's quite easy to just grab that password and actually be able to brute force it. So you want to use something like Kerberos, which is a shared secret model. It does require extra steps, but they're not actually that complicated. They basically involve creating the impersonation identities by putting SPNs in place. Again, just download this slide deck if you want the examples. You create those SPNs, which you need to be a domain admin to create them, but you create the SPNs. Once you create the SPNs, then you can also create the SPNs for SQL. So you actually create the SPNs between your SharePoint servers, web front ends, and the SQL servers. That's an important step that people oftentimes forget about when they're enabling Kerberos. And then also, if you're doing anything that requires impersonation, it's an extra step. This is only for the impersonation piece. This actually isn't needed for just the native Kerberos setup. But that's where you'd actually go through and trust the systems, the app pool identities, and the actual accounts themselves for delegation. And then enabling Kerberos, which just is turning it on the web application itself, which is the final step. I also include a fifth step in there, which is to go through and make sure you're actually using Kerberos. The downside to Kerberos is if it can't negotiate via Kerberos, it'll fail back to NT-LANMAN. So many times people will think they're using Kerberos, but they're not actually using Kerberos. You need to go in and look for event ID 4624 to make sure you're actually getting the logon events using Kerberos from the system itself. I've included also a bonus slide on the best practices. I mentioned this earlier. Setting up your SharePoint Central Admin for load balancing, SSL, and Kerberos all at the same time. Okay, and we've got like 1 minute for questions. But real briefly, take a look at the session takeaways there. I'm going to jump right into questions so that we have at least a second here. Yes, go ahead.
Thanks, Michael. Overall,
thank you.
Good presentation.
Thanks for the overall. I'm not sure what that means. But no, it's okay.